Hello students, and welcome for our next unit. This is all about congruency, and we're dealing with different types of triangles and proving that they are going to be congruent. We have a lot of proofs this unit, so if you're still struggling with proofs, please let your teacher know so that they can go through and help you with that. So let's go ahead and get started. So what does it mean to be congruent? So just to review it, in sense of we talked about it with angles and we talked about it with segments and things. So now we're talking about figures themselves and how are they congruent. And so to identify whether they're congruent, you want to make sure that they have the exact same size and shape. So for example, the one on the left here, you see they all have that exact same shape, and we're going to assume they have the same exact size, versus the ones on the right, you can see that these triangles aren't anything that they don't look anything alike. One is definitely smaller than the other. This one even doesn't even look like, has the exact same type of shape to it. Okay, so that's how you know that it's going to be congruent or not. So when you're dealing with congruent figures, there are the same number of sides. There are equal number of corresponding parts for angles. So all parts of one figure are congruent to the corresponding parts of the other figure. Incongruent polygons, this means that the corresponding sides and corresponding angles are congruent. Okay, so if I tell you these two triangles down here on the right are congruent, you can see by all those markings that's showing you that those three angles and those three sides are all the same. And so what we can actually do is list those out if we wanted to. So for example, corresponding angles. So if I ever ask you, what are the corresponding angles? I want to know, well, which angles are congruent to each other? So in this situation, it would be A is congruent to F, B is congruent to E, and C is congruent to D. Okay. We can also do the same thing with sides. So again, I'm just asking you what sides are the same. So for example, we have, the AB there is the same length as the FE, so those guys are going to be congruent. We also have BC is congruent to ED, and then finally AC is congruent to FD. So you can tell by the markings which ones are congruent to each other. And then we can create something known as the congruent statement. And these are very important for you to know and understand how they work. The order of the letters do matter. So when we're naming a triangle, say I was naming the triangle on the left and I just call it triangle ABC, on its own, it does not matter the order I do that. But when you're going to create the congruent statement that's saying the first triangle is congruent to the second triangle, take a look at the letters, okay? Now it's color-coded here to kind of help you. So do you see here how this red and this red go together because those are the corresponding angles? So, and that continues, the blue with the blue and the green with the green. Okay, so the order is going to matter. If we were to switch that order of the first triangle, we have to switch the order of the second triangle. So there are a bunch of different combinations, but what's important is that you're maintaining that corresponding sides and corresponding angles are in the same positioning. You can even find the segments, A, B, F, E. You can see right here, A, B, F, E. So that order does matter. Okay, so let's go ahead and do an example with that. So I would suggest hitting the pause button, trying this on your own, identifying your congruent parts of this triangle here on the right. Two sets of triangles. Sorry about that. Okay, so let's see how you did. Hopefully you gave it a try. So let's go ahead and show which ones were the congruent angles. For starting off with a congruent statement, we have JKL. And so as I went from J to K, I have to make sure I'm maintaining that. So T to S. So JKL is congruent to TSR. You could have a different combination of those letters, and that's fine as long as you're maintaining things are in the correct order. So the corresponding angles, J with T, K with S, L with R. And the corresponding sides were JK with TS, KL with SR, and LJ with RT. So as you can see here, what's going to be congruent to each other. Hopefully you did a good job on that. If not, please let me know. All right, so now let's use that to actually solve some problems. So in this case here, I'm talking about two quadrilaterals, and I can tell from the congruent statement what's congruent to what. So I know that D is going to be congruent to angle S, or even length DE is the same length as SP. And again, I'm telling you that these two shapes are congruent. So what we want to do is find the value of X and find the value of Y. So if I take a look at the one on the right, okay, I have QR. So what you can do is after you've identified what piece that you're looking at to solve for X, you can go look at your congruent statement. And I can see that QR is going to be the same length as FG. So you see it right here. I have QR is congruent to FG. So that's kind of the first thing you want to do is identify what pieces are equal to each other. So they're congruent, so that way we know that their lengths are equal. So if I substitute everything in, so FG is length of 12, and I know that QR is represented by the expression 2x minus 4. I can add 4 to both sides, and I can divide by 2. So I know that the value of X is 8. Okay? So now moving on, we're going to find the angle the value of y. So once again, I'm looking at where y is, and I can see it's associated with the angle Q. And if I look, angle Q is in the same spot as angle F. So that's helping me decide, well, which of these angles am I going to be using? Well, it's congruent to angle F, so that's the one that I'm going to use. Okay, so I'm going to set it where you have angle F is equal to angle Q, and I'm going to set those two things equal to each other. So 68 is equal to 6y plus x. So that's in red there because we already know what the value of x is. We see that it's the value of 8. So I could go ahead and use that. I'm going to subtract that from both sides and divide by 6, and I get the y value of 10. So this is a theorem that kind of seems like common sense, but is useful in some cases. If two angles of one triangle are congruent to two angles of another triangle, then the third angle is also congruent. So what this is pretty much saying, we know that the total sum for a triangle is 180 degrees. So let's say that this angle was, I don't know, let's go with 30 degrees. And this angle here was, let's say, it was 70 degrees. So that means that this angle here is also 30 degrees and that this angle here is 70 degrees. Well, what this theorem is saying is that no matter what, angle C has to be the same as angle F. That's pretty much what's going on here. And that kind of makes sense. Both of these things are the same, so they're both going to add up to 100, which means what is left has to be the remainder of this thing. So we know that both those are going to be 80. Okay? So that's kind of the big idea behind that theorem. A lot of words just to say something you probably already know. So let's go ahead and take a look at that and kind of apply it to an actual problem. So we have here two triangles. We're trying to find the measure of angle BDC. So that's this angle right here. I have some important information. I know that angle A is congruent to angle B, and I see that this little angle down here is congruent to this little angle down there. And so what we're kind of looking at are those two triangles that are sitting on top of each other. So here's one of them. And here's the other one of those, okay? All right, so now as you can see, two of the angles are going to be congruent to each other, so we know that the 45 and 30 is going to match the 45 and 30 of the other one. And so we know that the last third angle of these two triangles, or the big obtuse angle here and here, are also going to be the same measures, again, based upon that theorem that we just talked about. So angle ACD, I know we will take 45 and 30 and subtract it off of 180. That's something that we've been doing. So I know that that angle is 105, and since the two angles are the same, that angle BDC also has to be 105. Okay, so we've talked about the reflexive, symmetric, and transitive property of equality and congruence. I just want to let you all know that those same properties apply for triangles as well. So when we do the congruent statements, we could say triangles are congruent to itself. It doesn't matter which side. That's the reflexive property. The symmetric, which allows it to flip-flop, it doesn't really matter which side it is. And the transitive property as well. So if the first triangle is congruent to the other one, that same one's congruent to a different one, we can essentially take out DEF and we can focus on those two triangles there. Okay? So those properties still apply to triangles. All right, that's it for now. Go ahead and hit pause and start the practice. Let me know if you have any questions.